So, as if none of that happened, good afternoon, everyone. How are you all doing? That's very cheery and very happy. I'm very glad about that. But I come with a warning, and it's a simple warning that hackers are everywhere. And I don't mean the cool kind of hackers like the people that we are right now, just making stuff, building things in a field. I kind of mean people like this guy. You know the type. They're in their suit, their balaclava, hacking and breaking into your users' accounts. People like this woman who is so good at hacking, she's managed to get herself a laptop whilst in jail. And people like this man who I don't know why he's got sunglasses on inside a darkened room, but whatever he's doing it right. He's keeping his fingerprints safe. He's got the gloves on. That's cool. But whatever he's doing it right because there is money pouring out of his keyboard. Hi, my name is Nash, and I'm a developer evangelist for a company called Twilio. Who knows what Twilio is here? Anybody? Quite a few people. That's cool. That's cool. If you don't know, which I'm sure one person did with their hand up there, Twilio is a communications platform. It's a way to communicate with your users via voice, video, or messaging using the tools, languages, or frameworks that you already know. And I think it's pretty cool. And that's why I work there. But it's not about Twilio right now. We're talking about two-factor authentication, or 2FA, what the two-factor authentication. I've got a bit of a straight up explanation of that, but we're going to go into a bit more than that. So two-factor authentication is a security process which a user provides two different forms of identification to authenticate themselves with the system. Those two forms must come from different categories. That's important. And normally it's something you know and something you have. A great example of this that we've been using for years is bank cards which have a PIN number. You know, that is something you have, the card, and something you know, the number. But like, why is this important? Like, I mean, do you have two-factor authentication set up on all your accounts, right? If anybody's saying no right now, you're excused from the rest of the talk so that you can go and set that up for yourself because you're more important than everybody else right now. Sort that out. But there are many reasons why I think this is important. And one of them is based on the story of this guy, Matt Honan. He's a journalist, used to write for Wired, and back in 2012, his digital life was destroyed by people without very much technical ability whatsoever. And I want to tell you about that. I want to tell you how they did that, and we'll see why I think two-factor authentication is important. So we have a bit of a timeline of what happened. They found his Gmail address on his website. That's perfectly reasonable kind of thing. You probably have your email address on your website. And they entered that into Gmail and found that he had a me.com account, one of those people, as the backup email address. And so they called up Amazon in order to add a credit card to his file, which was nice of them, I guess. Of course, like, you don't just add credit cards to people's files. You have to talk them into doing it, right? You had to, I mean, they were after passwords or secret identification, things like that. But eventually, because he couldn't give any of that, it boiled down to being able to tell them his email address and a billing address. Now, he had the email address, obviously, we found that already. And they found, this is about the most technical part of this hack, they found the billing address on Whois for his domain, right? So they have billing address, email address, and they added a credit card to his file in Amazon. He wasn't aware of this at the time. And then they called him up again. And said, all right, I need to change my email, get my password reset to it. And they would go through all the same questions, all the same things. And eventually it boiled down to they needed his email address, his billing address, and the last four digits of a credit card they had on file. So you see, I wasn't kind of as nice as they were trying to be. So they got the Amazon account reset, which is kind of cool. And then they called up Apple to reset his password. And he actually as a journalist, he went in and worked on finding out how they did this. So we actually get a timeline here from Apple support. At 4:33 p.m., he called Apple to, the hackers called Apple to reset the password. And, they went through the same thing again. All the security questions, all that kind of stuff, which they didn't know the answer to until they asked for an email address, a billing address, and the last four digits of a credit card on file. Since they had the Amazon account, they had all his credit cards that were on file and the last four digits for them. So that was how they got in there. And they reset the access, reset the Apple ID password and gained access to his me.com email address, at which point they reset the Gmail account. And this is where it gets nasty because then they wiped his iPhone. They reset his Twitter password, hacked into that, wiped MacBook, deleted his Google account, And at 5:12 p.m., just like about 40 minutes after getting onto Apple in the first case, posted to Twitter to take credit for the hack, which was nice of them, I guess. Weirdly enough, in the 10 minutes they had control of that Twitter account, they posted racist and homophobic slurs. So I don't know why you'd take credit for that, but that's what they did. And the whole thing was, the whole hack, the whole reason they did this was purely to get Matt Honon's Twitter account, which had a 3-letter name. That was basically it. It's kind of nice, really, because they could have done so much worse to him. Although that he did lose like pictures of his child that were on his MacBook and iPhone that wasn't properly backed up. So that sucked. But what really sucked is that at every single stage of that hack, at the Amazon, Apple, Gmail, Twitter, any single stage of that hack, two-factor authentication would have stopped them in their tracks and saved whatever account was blocking. If he'd had to have something like, if the hackers had to have access to something that Matt himself had on his person, they would never have got in. Very sad story. It's good to find out how it all happened and that this can be avoided. I mean, there is some social kind of hacking in there as well, but that's it. But I have more reasons why this is important, because we're not all just in control of a highly desirable Twitter name like Matt and leaving bits of data around like that can be tampered with. Maybe we have, maybe we have long passwords. Maybe we have password managers. This is probably the kind of place where we all have things in password managers. I don't. I'm sorry. I'm pretty bad at this. But this is also probably the kind of place that you would find people like that. However, there's many other people in the world who definitely aren't using these kind of things, aren't using long and different passwords for every account. And so I want to play a bit of a game. I don't know if you're aware, but Ashley Madison is a site that was hacked last year for apparently ethical reasons, and it turned out at some point they had not been hashing their passwords correctly. So a security firm was able to break 11 million of them. And so that means we get the top 10 passwords used on ashleymadison.com. Does anybody want to have a guess what number one was? Password. Oh, it's in there, but it's not number one. 1, 2, 3, 4, 5, 6. Yes. Wonderful password. And then 1, 2, 3, 4, 5 was second. Just slightly lazier people, I guess. I think password's number 3. That's good. And then default in caps. I genuinely don't know why that one's there. Some people made it all the way to the end of the keyboard. Some people just did the letters. That's fine. 20, 3, 4, 5, 6, 7, 8. Not quite all the way. I don't know. ABC 1, 2, 3. That one's a little bit bit of work to do on the keyboard there. It's not just like swiping a finger across things. Number 9 wasn't the characters. It wasn't the characters NSFW, but I'm not putting what it was on screen in the context. You can ask me about that later, after a couple of beers. And finally, 1, 2, 3, 4, 5, 6, 7. But what the worrying, the terrifying thing about this is not just that people are using these, but how many people are using these. That's 120,500 people with 1, 2, 3, 4, 5, 6. And this is a site that you probably want to keep relatively secret. I don't know. But basically, users are bad with passwords. And then we know these passwords because sites are bad with them as well. You are almost certainly in control of an account somewhere that has lost all of its user data and is on the internet for everyone to use right now. I forget the name of the site. There's a site called Have I Been Pwned or something like that. And it's really terrifying because it emails you if you end up on one of these public lists of places where they have your email address and a password that you used on an account. It's really useful for that, but it's also terrifying how many emails you get. So users are bad with passwords. Hackers can make their way around passwords an awful lot of the time, and we need to stop that. So how are we going to do it? Two-factor authentication. Your normal user registration flow is fairly straightforward, right? You visit a registration page, you enter your email address or a username and a password, and you're logged in, and that's fine. And then similar for when you go and sign in, log in. You visit the login page, enter the username and password. Hopefully it's a securely hashed password, and that is then verified, and you're logged in. Brilliant. Let's get over that because that's not good enough. SMS is the first kind of way you might think of doing two-factor authentication these days. And it's pretty useful. I like it. It's what we do at Twilio. We have quite a lot of SMSs. And it's a fairly straightforward addition to the flow, because you just need to take somebody's phone number as well. And that's fairly straightforward, and people are kind of happy to give that away for security reasons, which is nice. It's not for spam text or anything, so that's cool. But then, when they log in, they enter the password. As long as that account is right, we've passed the first factor, then the verification code is sent to the user via SMS. And you can do that, as I said, if you use an API like Twilio. That's probably the easiest way, and I wouldn't even know how to do it otherwise. So do that. And then the user enters that verification code, and you have to just make sure that was the code that you had. At this point, it can just be like a random number. It doesn't matter. You could save it in a database column, being like, this is the login code for this time around, maybe with a timeout on it, something like that. And the user's logged in. But there are pros and cons to this. One of the big pros to using SMS for this is very much that most people in the world have access to a device that can receive an SMS. And it just brings this ability to have security and have a safer account to almost everyone in the world. It's super useful for that. On the con side, SMS obviously costs. To be able to do this, you either need the infrastructure or a service in order to do that, and so that's going to cost money. Security is worth it. And SMS is not the safest thing. It is a clear text format. If you can put your own... there have been many hacks recently showing people being able to take over things that are based solely on an SMS message, and that's a little terrifying. So it's not the most reliable, it's not the most secure method. However, in terms of making this available to the most number of people, SMS is probably the best. But then we have soft tokens. And by a soft token, I mean where you have an application which can generate that code for you. And so in this particular case, the registration flow becomes, you do the normal stuff, and then you generate a secret, a cryptographically secure, long kind of secret, and share that with the user somehow, and get them to verify that they have that with the code probably, and then they're logged in. And then when the user logs in, they just have to open up an auth app. You're probably aware of Google Authenticator, and Twilio also owns a company called Authy who has an application for this, which is very good. So you open that app up and get the code out of there and enter it on the site. That gets verified and logged in. And so I want to talk about those secrets, because this is what interested me, and this is what kind of drove me to investigate this a lot. Because we have this application that can be offline, it can be out of the it can be out of any network. It does not need a connection to the site in any way in order to generate these codes, and that's always interested me. And it's all down to this protocol, the HOTP or TOTP protocol, which stands for HMAC one-time password and then time-based one-time password. And this is what that is. It's a nice little cryptographically cool little thing that uses the HMAC digest. And when you do HMAC-based one-time password, you use a key, a secret key, which is that secret you generate for the user, and then a counter, which you have to keep updating. And to make the code, you just take the HMAC digest of the key and the counter. You use truncate. In this case, is it's a deterministic way of picking 4 bytes out of the middle of the digest somewhere, and then that's just a bit mask to make it a positive number in the case of signed integers. And then your actual value, the 6 digits or 7 digits that you've probably seen when you do these things, is taken by modding that result to 10 to the number of digits that you'd like. Straightforward. It's easy. It's fine. If you do want to, if you are interested in seeing that in more detail, I kind of recommend taking a look through this Node package. If you like or don't like JavaScript, it doesn't matter. It's very easy to read, and it just spells everything out in front. And it just, as long as both sides have that secret, they are going to create, and the counter is in sync, they will create the same code every time using that algorithm. And then the time-based one-time password is exactly the same as the HMAC-based one, except the counter that you use is simply a number of periods since the epoch. This is the period length tends to be 30 seconds. That tends to be how long you have to get your code typed in before the thing changes in your app. But that just means the counter can be based on the time, and so we don't have to worry about keeping them in sync any more than we have to worry about generally keeping clocks and time in sync. So actually, I wanted to just show this very quickly because I really like that NOTP library. And I just want to show you how it works. And can you read that? Or should we make it bigger? That's cool. So I'm just going to kick into Node and get myself the NOTP library. And there it is. And so it comes with HOTP and TOTP as things. So if we get HOTP off of the NOTP object, then we can see we get two functions of that, generate and verify. Gen and verify. And so when you generate, you just need to use a secret, something secure, something that's not hello. But that's what I like because it's easier for me to type that than a 16-digit random string. And if we put the counter in as 1 right now, we can generate ourselves a code, 825147. Wonderful. And if we run the same thing again with the same counter, it is, of course, the same. And then you move the counter, and it's different. Wonderful. This is how easy it is to produce this stuff. And then on the other side of things, you want to verify that, at which point we're going to take that original number that we got back, 825147, our secret, and the counter at the time, which was 1. And we see we get an object back. And if that was incorrect, if something was wrong there, if the code was out by some sort of digit, you get null back, which of course is false. JavaScript. And that's as kind of easy as it is. What I really like is this delta, which, oops. What I really like is this delta, because if I change the counter here, because we added in the, we added the code in, but maybe the counter was slightly out of sync. Oh, that was the wrong one. If we change the counter, we get a delta of -1, which shows you like we're close. Like this, the person is making the right code. They have the right secret. They're just kind of out of sync slightly. So that's where you can update. And then the same happens for TOTP, which is really great as well. And this one's easier to generate because you just have to pass in the secret because it's based on the time. So we just get a code out of it. And if we keep generating them, they'll be the same. This is the point of the talk where I have to wait an indeterminate amount of time in order to get a new code out of this. Nope. I'll get on with verifying. Hello, and the code goes first. So 953767. It's going to have changed now, right? So we have a delta of -1. And if we generate again, we have a new one. And so that's how the time-based one-time passwords work. And again, that delta just shows, firstly, that the person probably has the right secret. But secondly, it also means that as a user, you don't have to rush. You just have to know the number. It's going to be fine if people have implemented this correctly. So I think it's really easy to generate these things, and it's pretty cool. All you have to do is share the secret somehow, and that's kind of not the difficult part, but it's just another thing to think about, because most of the time we do it using QR codes, and I love QR codes. Said no one. I guess. But they are, I mean, this might be the only good reason to have a QR code on a website ever, is to keep people safe. And if you want to generate a QR code, you use this kind of URL format that has the protocol OTP auth, the type, which is then HOTP or TOTP, a label, which is pretty much your application name, and then some other parameters that include the secret. And so that's a bit small. But if you can see, we've got OTP auth and TOTP is the type. The label in this case is example because it's my example application. And I've also put kind of my email address into that as well. So you can see if you have multiple accounts in one app and you have multiple two-factor authentications for it, then that will be read out for that particular account. And then in the parameters, we have the secret, and then the issuer again, which is the application. And I like, as I said, QR codes are great. This is still my favorite blog on Tumblr. It's been going since 2012 and still has no posts. It's genuinely my favorite. But I do think, this is a useful thing. It is a useful thing for security. There are pros and cons to this, of course. The cons being that most people, so in order to do this, you need to have some sort of smartphone. Any kind of feature device is not going to do the job. And that counts some people out. And the sharing of the secret is a weird one because it can be captured, especially if it's a QR code kind of thing. It's being displayed on a screen, and if somebody is that paranoid about the thing, it could be captured whilst they're doing sign up registration for this kind of thing. So you can give it away. Similarly, in the cons, you also have to look after those secrets on the side of the users. You can't hash them. They have to be held in clear text in your own database. So you have to look after this secret, which people believe to keep them safe. But can this all be better? Because the problems with security and with things like two-factor authentication tends to end up that we lose out on user experience. Having to open your phone and get a text message or open an app and type in a code is all a little bit awkward. And I think it can be better. People have said to me before, friends don't let friends write their own authentication frameworks. And I work a lot with Ruby and Rails, and so Devise is a open source authentication framework, which is a wonderful, wonderful thing because I don't have to worry about screwing all the things up that you can screw up. And I believe that's probably the same for two-factor authentication as well. I don't want any of us to screw this up, and so I want the professionals to be sorting this out. And that is why I mentioned Authy earlier, but it was a year and a half ago now that Twilio bought this little company called Authy because they were doing two-factor authentication as a service. Effectively, it's kind of 3 API calls in order to get everything you need in two-factor authentication. And when you register, so just to give you a bit of an insight onto this, when you register with Authy, you do need the phone number off of the person because text messaging is the very much base of the whole thing. And your system then makes that first API call to register the user with Authy. And you get like an ID, and that's where you have to store the Authy ID of the user. And then when they log in, you just you make one API call to send the authentication request. And that can come via SMS or via a push message to a push notification to the app. So that's why we just have Authy prompts the user somehow. And then they find the code either in that SMS or via the application. And enters it on the site, and the final API request that you have to make is to verify that code was correct, and then they're logged in. But that's not all. Like that doesn't change things much. The Authy application on the phone is better than a Google Authenticator and is more looked after and more up to date. But we need more than just a slightly better app in order to make this interesting. And so I think the future does come a bit down to push notifications. If we've already got people with an application in their hand in their phone or whatever, then we can do more stuff with that. And that's a thing that Authy calls One Touch. I just want to show you a quick demo of this as a video. Okay, I'm going to do this really quickly. So when you log in, on the side is my phone. I'm sorry about that. On the side is my phone, and when it logs in, it sends a push notification. But what's going to happen is you're not just going to have to type in a code, but it actually asks you, this site is trying to get you to log in. Is that cool? And you're like, yeah, that's cool. And then it logs you in, which is much better, I think, much better experience than having to type digits, having to type all those things. I'm going to rush through this last bit. I'm very sorry. Pros and cons. It's pretty awesome. You have to have an app, I guess. In summary, users are bad with passwords. I'm bad with passwords. And so many users. Other websites are bad with passwords, and they leak them literally all the time. Two-factor authentication can be push, a token, or SMS. And to me, that seems a little bit like kind of graceful degradation in kind of websites, in that you use the thing that most people will get and improve upon it if you can. And two-factor authentication really is for users and really is for their security, their experience, their entire life and their world. If you are, if you think back to Matt Honan's story. So that is all I have for you this afternoon. Thank you very much. Let's beat this guy. Let's stop him stealing padlocks out of the top of your oil bars or whatever. I don't know. Thank you. Thank you very much.